All right, hey guys, I wanted to work through just real quick, kind of an outline for assignment 6 and how you might go about solving this. So looking at this assignment, the first task has you import 100-acre wood data, and it has you do mean, median, standard deviation, range. So I want to show us some ways that we could do that. So I'm going to click save and then run it, and we'll see all this is popping up over here. But looking at task 1, so here's the histogram that I created. Now, yours can look a little bit different, but basically, I have my masses, and I can say range equals range of masses, and so that's my capital range, right? I found my max and my minimum. This is not something you have to do, but I'm just showing, my lowercase range is taking my maximum minus my minimum, and that's my range, and so both of those produce the same result. If I wanted to, I know my range basically goes from 79 to 131. So I could create x values from 70 to 140, and maybe I went by tenths. Right? Now, if I created my histogram and said these are my masses, and I want my bins to be 70, 80, 90, 100, right? I could run it, and my graph would look something like this. So it's a little bit different, okay? That's my x values, right? So it depends on how you guys want to do it, right? If I said, every 5, I'm going to make that go away, save it and run it, then that again, it's going to give me a histogram that's going to look a little bit different for task 1, right? But hopefully that helps with kind of how you can set up task 1 there. Task 2 is a lot more confusing, personally. And so let me walk through how you might do this. So task 2, we import the data of the phenotypes, and we create a histogram. All right, that histogram is this right here. So we have our A's, our B's, our AB's, and our O's. Right? Now what we can do is we can actually use histogram to tell us how many things there are. So with this histogram, we wanted 4 bins, right? And so there's 4 different sets of data. So I said counts equals histogram of blood. And what that does right above that is it says counts, and it tells me actually how many are in each bin, 200, 301, 305, and 302, or excuse me, 32. That is going to equal 838 if we add them together, and I had MATLAB do that by saying total equals the sum of counts. Counts is just how many we have in each one. I want to add them all together, and that gives me the sum, or the total, right? And I can look at my variables here and say 838, and hey, yes, 838 is what I get. Awesome. The next thing that it has you do is it has you do the percentages. So this is something that's new. This is indexing, right? And we'll talk about this a little bit more in class. But indexing is where I want it to take the first value of counts. So the percentage of A's, people with blood type A, is basically my number of A's, which is this, divided by the total number of people times 100. So counts 1 is this. It's the first value in my array. So it's 200. So it's going to take 200 divided by the total, which is the sum of all the counts, and multiply it by 100, and that gives me my percentage. Percentage of B is counts 2, which is the second value in my array, right? So that is, I know it's a lot of back and forth, 301. So 301 divided by 838 times 100, and we can see the percentages here, 23%, 35%, and so that's how I'm getting that there, okay? The last part then has you look at the genotypes and kind of compare genotypes, all right? And so what I'm going to show again is these are my genotypes. This is a histogram of my genotypes, right? If I were to look at the genotypes, everyone has either an, this person is a AB, right? Or no, this is a BB, I believe. BB, right? And so you can look at the pairs that everyone has, right? 2, 3s, or 5s, and understand, what each one is doing us. So you can use this idea of like we did up here with counts of figuring out how many each of these bins has, we could add them together and figure that out, okay? So I'm going to leave that to you. Again, this is called indexing, right? If you want to try to figure out how I can then index for the second part of task 2. But hopefully that's a good just kind of starting point. Start here. Now, how can we use this information and complete what the task is asking us to solve?